Now I'm going to talk about the implementation. We have used the OPL language, which OPL stands for Optimization Programming Language. One of the main features of the last version of this language is that you can use different engines to solve problems. One, for example, this CP stands for Constraint Programming, and you can solve a scheduling problem including interval variables, state function, and so on. And you can also use a completely different nature of engine, which is Cplex. Cplex allows you to deal with linear and integer programming. In this particular problem we have used integer programming. So basically what you do in the objective language style, you define a new model. This new model is going to deal with the scheduling, and here you are specifying CP, which means that you are specifying they are going to deal with constraint programming. We use it only for graphical and consistency purposes. Then the Cplex module we create a new object, and we do use integer programming fully engine to satisfy the main objective. So when you run the program and you get the solution, basically what you are doing is to communicating the data that you get from one model to the other model. So when you run the problem and you get this result, here these are the interval variables that represent these activities, and this state function represents the state in which the track are in the different line of times. So when you click on this icon, what you get is this Gantt chart, and this represent the sequences of activities: loading, transport, unloading and crashing, and transport from the winery back to the farms. And here you have a similar sequence, the 4 activities, and each row of this Gantt shows you the formally an interval variables. Conceptually it is one activity. In this case this activity represents the transport from the farm to the winery. And then when you click on this icon, then what you get is this detail about the line of time in which each track has been. So here basically you can see all of the state in which this particular track have been during this timeline. So one track is represented formally in this model by one state function, which in the previous version of the OPL language they were called resource. So basically what you have here is one model which you use for the secondary objectives, which are reuse of tracks if possible, reduce total track consumption, and reduced weight of tracks. And you have the main objective, which is found using the integer programming model. So when you start with the integer programming model with Cplex, and then you fulfill the main objective, which is to maximize the quantity of grapes measured in terms of tons that are crushed in the winery, and what you're going to get with the integer programming model is that the optimal solution is found using 4 activities with this kind of track. So you have 1, 2, 3, and 4 activities that use this kind of track that load up to 10 tons, so it's kind of smaller. Then you have the normal track, and the integer programming engine tells you that the optimal solution is found with 3 activities, 1, 2, and 3, that you perform with this kind of track, which allow you to load 15 tons. So that's why if you see the activity is a little longer than these activities performed by that track. And finally, the integer programming model tells you that there are going to be 5 activities performed by this big track, which are 1, 2, 3, 4, and 5. These 5 activities that are performed by the big track. That so it allows you to load 30 tons. That's why this activity is quite bigger than much bigger than the other one. All of these activities that are performed in the winery has to fit within this temporal window, which is the time in which the winery is open. So the integer programming modules tell you that 5, 3, and 4 constitute the optimal solution, and then the schedule modules find out the secondary objectives that are related to the duration and structural composition of these activities. When you run the program, you get this result. The reuse of track is this variable that tell you 3, because 3 times you have reused tracks. The total track consumption, which is this variable, and then the weight of tracks, which is these variables, and finally the total winery weight, which is all of these secondary objective. With all of these variables, you build up a total cost function, which is basically a function of these 3 variables, and you can, with a normal style, you can weight the different secondary objectives in order to give you more priority to one respect to the other one. The conclusion and future work: the current version is a prototype, so basically we should test and adjust the program to the real applications. Second, the task that we have performed is basically the daily scheduling, and we should try to enhance these ideas, trying to cover other part of the total wide supply chain. Regarding the main objective, which is to maximize the quantity of grape crushing, the optimality is guaranteed by the OPL language itself, because the integer programming module guaranteed that the solution is going to be optimal. However, the secondary objective is more difficult to measure up to what extent the solution found fulfill the target that we are aiming to. So we have to resort to the expert to tell us whether or not the solution are good. So we should try to use different strategies to improve the solution. You can never be sure that you really attained the optimal, because as there are secondary objectives, there is no formal optimal. And that's it. So thanks for your listening, and see you in the next video.